Hello viewers, once again from our Alien Lab here, visiting your video from our Alien Lab. Once again 2015, here is Yuri James K, ready for our own first video in our Alien Laboratory that is going to debunk the myth of electric conductivity of both a guava plant and what we call banana. Now, it is important to know that the test itself is going to prove much more about the bananas and about the bananas and about the guavas, just that we shall always be able to see why do bananas conduct electricity, why do guava conduct electricity, and do they conduct electricity like metals or not? Are they more superior to metals or to ions or to substances that have electrons or not? Now, that will be our subject. Furthermore, this program is supported by straighteners, cleaners of carpets and sofa set. Now, without wasting much ado, we are going to start our experiment here, and we shall require the following. In our experiment today, we will require one marker. Have to do some mathematics there in case. We shall require some soft brush. We are also going to require sharp edge conductor. In this case, we have knife and a scissor. We are also going to require some size D batteries, and we are also going to require some button torch. We are going to do the test involving therefore both ripe and low guavas, and another thing is both banana which are ripe and low. What we are using there is already on that box, and you also have to require some cards here. Some cards will be required for our test, so that we are able to establish the nature of that voltage. And you can use any kind of a card, but the different cards are much more important to use. It is important to use different cards of different density. Okay, now with that, we can start our experiment here. And before we start every experiment, we have to recheck the apparatus that we are using, so that every kind of apparatus will be working. And we have a multimeter here. A multimeter is used for testing both voltage and current, and also resistivity and continuity. For the part of voltage, our multimeter is correct. That is the part of continuity there. The beeping sound indicates that on the side of continuity also our multimeter is working. You can set it at a scale of 20. I think we are going to use voltage that is not above the 20 scale. Now you also have to use a receiver. In this case, we are going to use it where it is a medium wave. You learn how to use the receiver once more, test the voltage on a circuit, and we are going to use it as is there. Also, we are going to use a K500 ramp, which is a LOD ramp that is able to detect very low voltage across the circuit. As you can see, it's very bright there, but more part of it, although it can be used for house lighting, it can be very, very useful when it comes to testing low voltage through in a circuit. So, without wasting much more time, we are going to go direct to our own experiment here and do what we need to do here to execute our experiment. Okay, let's here is 20. That is correct. Okay, now I will test that. We have our bananas here, both ripe and low, and guava here. We have them both raw guava and ripe guavas. The decision to use both of them is to indicate the changes that occur to both of them when they are ripe and when they are not ripe, like that. Now, when it comes to metallic substance like this, we know that the metallic substance like this conduct electricity because they have electrons or free electrons. But when it comes to acidic, here I have some acid I have made from some leaves here. When you come to acids, the property of the vehicle that deliver the current is always ions. Let's see whether you can see from our multimeter there, the reading there. You can see from our multimeter. See up there. You can see from our multimeter there. No, let's see. I've detected something. Yeah. It's a weak acid, not a strong acid. You cannot use. Yeah, you can read something like 0.03. So, in case of an acid like this, the vehicle that deliver the voltage or the electricity is ions. But now for the guava here, what is delivering the voltage here? The vehicle for delivering voltage is neither electrons or ions. Now we are going to learn what is that from our own experiment here in Iron Lab. Now you just need to poke one hole from one side of the guava and poke another one so that the two are joined by the guava themselves. But make sure that the two metals are not joining in themselves so that they are not touching each other. You can come here to a battery house here, which you use there to increase the voltage, and slowly join the guava there from the side of the knife, and from the side of the scissor you also join the guava. Then we can see when I switch on from my button switch here, we can see the lighting there of the diode, that the diode are lighting, although they are lighting or the light that is being produced by a K500 lamp is dim, but nevertheless it indicates that the voltage is flowing across our guava there. So that means that guava is a conductor of electricity. Now we know it is conducting electricity. One might say that it's conducting electricity because of the ionic relationship, but that will be proven out after several experiments that we are going to do here. Now we can continue with the test and add another guava here, poke a hole like we have done there before, so that the two guava now faces each other, and we don't have a metal conductor connecting the two. As you can see, the LED lamp continue to light, although dimly. Therefore it means that it's not a must that you have two guava connected by a conductor at the center so that the guava themselves conduct electricity. The PD or the voltage continue flowing across the two, although then we don't have a metallic substance that is joining the two of them. So you can see, as you know now, if you have not known this, that the guava or the plant as they are, they can be able to conduct electricity themselves without we as using what? Using metallic substance. The conductivity there is there, but it is somehow dim. But it can be indicated there. As you can see, it can be seen, although it is dim, you can see that we can be able to run voltage across the two guava like that, although we don't have any metallic substance at the center of them. Now, that is as far as we go in a part of a raw guava. So what happens when we use the guava when they are ripe? Now you will see a very good difference here, because these are ripe guavas, and I poke the hole like I had done there before from this side, and I also poke a hole from this side of this guava. Yeah, you can just first fix them the way they are. Yeah, you see the current is detected there. The K500 lamp indicates some voltage. Yeah, you can see voltage is there. So when we join the two now guava, so that they face each other without having a metallic substance from them, and we will see what happened. Have another guava here, and we have one just right here. So guava at least. Can use this one which is closer, and you see what happened there. Whenever we use ripe guava, the ability of the guava to conduct voltage appear to diminish. It appear to go down as the guava ripen or ripen. But as you have seen there before, when we used the raw guavas, this one, we could be able to conduct electricity when both of them did not conduct or connect to any metallic substance. Therefore, you can easily know that there is some particles inside this guava that is making them being able to conduct electricity even when we do not have a metallic conductor joining them. So let's see what I'm trying to talk here. Let's not switch here. I think we had done that before. We may not need to repeat it again. So you can see, as you can see now, the LED lamp is lighting when we have two guava joining each other. So using our torch here, we can be able to prove that there's no spillage of any chemicals or any acid outside here that is conducting the electricity. So what is conducting this electricity is not actually ionic or electronic relationship. What is that? That is what we continue investigating in case of banana. So we can use a banana. We start by using a banana that is raw banana. You can cut it into two like that, just like we had done to the guava. Let me see what will happen. Here I have another banana here, and faster I can join it with a K500 lamp from that side, and here we also use this one. So yeah, upon touching, upon close touching there, you can see already voltage is being conducted by K500 lamp. You can see the diode there indicating that there is flow of electricity from that position. Now we can also use our K500, our receiver here, to indicate the voltage flow. And I've said that the cracking sound is what you hear when there is a voltage flow. You can hear it there. Yeah, when you hear that cracking sound, it indicates that voltage is flowing across the two hot bananas. So our LED lamp is not lying, because our test from our radio here receiver have indicated the same. So we are going to continue with the test here. There's somewhere that we have a loose wire here. Shall rectify it within a minute, so that now you can use our multimeter here so that we can measure that voltage when we see what is happening actually. Then from our multimeter here, okay, if the scale is correct, yeah, you can see that a voltage of almost 1.5. Okay, let it settle. Let's see. Yeah, 2.61 voltage is being conducted across the two bananas. So the scale of this multimeter keep changing, because what is happening between the two bananas? There are some electromagnetic or electromotive force or electromagnetic force or electromagnetic current which is being developed at the center of the two bananas. Now we can break the gap there and measure the current from this side, or measure the voltage from this side. Now let's see what happened to the voltage there. Let's see, we shall see slowly by slowly what is happening from voltage. Before long, yeah. Now you can see there that let me bring that proximity that can be seen from now look at it. You have some voltage of 0.56. Now when you bring this closer, the voltage appear to diminish. But when you bring the bananas apart, the voltage appear to increase. Look again. I bring them closer, the voltage increases or decreases. I bring them apart, the voltage do what? Increase. You have to look at it again from a side of the banana here. What is happening? When I bring the banana closer, here, look at what I'm doing here. These are two bananas here, and I'm touching one side of the banana. When I bring them closer, the voltage appear to disappear. But when I bring them far apart, the voltage appear to increase. So why is the voltage increasing here when I bring the bananas apart? It is because there is another distraction, electromotive force or electromagnetic force that is being developed here, which is distracting the original flow of the voltage. As for the length zero that stays there for that current flowing through a conductor, in this case our conductor is banana, produces an electromagnetic force which appear to oppose the original direction of the current itself. That is why then when I bring the banana closer like this, we see all of a sudden decrease in voltage. But when I try to separate them like that, then the voltage increases. Now we shall investigate that as we continue. Now for the banana, the conductivity is not like the guava, so that when using a ripe banana like this one, it appears that the ripe banana conduct more or is more efficient in conducting electricity than the raw banana. So let's do the same thing we have done there with unripe banana there, so that you see what happened. So here you have a ripe banana, not to be eaten here, but actually for the test. And we do the same thing we have done with the guava and even the raw banana there, and see. Now you see, when I join them, the voltage or the current is flowing across the two bananas, just like it was flowing through there. So there is difference between the banana conductivity and the guava conductivity when they are raw and when they are ripe. The banana appear to increase or to become more efficient as to become ripe. Now it doesn't matter then whether we use a raw banana or a ripe banana, but the voltage is still getting conducted like that. So what is this nature of the voltage that is jumping from this side to this side? Now we need to do a very good test here by separating the two bananas here with a card. This card here, we have to test it through continuity test, so that someone cannot say that this card is a metallic card. You know, someone can say this card is a metallic card. The continuity test is very good at testing the metallic substance there, because there will be beeping. There will be beeping of the sound there. So you can hear there is no beeping of the sound on the side of the card. So you can easily say, like, see some what happened for a metal when it's tested against this the same thing. So you have to produce some beeping sound. You have to do a continuity test there. Alright, so see what happened. Beeping sound is correct. Test off. I am the metal which are tested. So we can test that card and we don't hear any beeping sound. So it means that our card here is not metallic at all. Our card here is not metallic at all. No beeping sound. Our card meaning that our card is not metallic. So we'll come and separate our two bananas there with a card, which is, this is a paper, therefore paper cannot conduct electricity, and see whether there will be conductivity of this voltage even when we have a card separating the two bananas. Let's see what happens. If you look carefully at the K500 ramp, you will see that the two diodes at the top and at the bottom, they are writing. So it means that the nature of this voltage that is flowing through these bananas is neither electrons oriented or ionic oriented, because there is no spillage of any liquid at the center of them. So it means therefore what is conducting this electricity is very unusual path. We cannot call it electron, we cannot call it ions. It's something that is neither ions nor electrons. Now you can continue to do more tests by using more denser card, more denser card. In this case we can use Safaricom. This one is more denser card than the card we have using here. 1963, I don't know what M-Pesa. Put it at the center. This one is more denser now than the original card. You can see very carefully that after we separate with the card which is more denser, the electromagnetic wave that was conducting the electricity, or whichever thing that was conducting the electricity from this side of banana to the next, does not or is not able to penetrate this more denser card. Therefore, meaning what is happening here is that there is conductivity of electricity by some kind of a wave. We don't know whether they are rays like gamma rays or beta rays, but they cannot be able to penetrate a denser card which is plastic, but they are able to penetrate a card which is less denser, here. In this case we have this card as we had done there before. You can see the detection of voltage even if we are separated by the card. So we can continue doing more tests here to indicate what is happening, and instead of using that, then we use a carton which is still more denser. Carton is more denser, at least like that. It's more denser. So you see, a carton originally without a hole do not allow any voltage to be detected by a K500 lamp. But when we use a carton here with a hole at the center, look at what will happen when you use a carton with a hole at the center. Now here I want to be very careful at what I'm going to do here, because people might say that the two are meeting, that's why there is conductivity. You can see now the banana themselves are not meeting each other, but still we can see that the voltage is being conducted on the other side of the LED lamp, meaning that the nature of this kind of what we are using here are the nature of the wave that are being, or the nature of electromagnetic wave that are being produced by the bananas are able to penetrate through a side that have no medium. You see, now when I remove my carton like this, you see, you can see that very well, that you can see therefore the voltage is being conducted like that. So it is very, very important to notice that we can even use two of them for more separation, so that you see what I'm trying to say here. When you use two of them for more separation there, we shall see what happens. See therefore, even with the two of the card there, yeah, two of the carton with holes, you can see that there is conductivity of voltage across by just using our bananas here separated by card. So in short, it is said that the voltage is being conducted by this, which is being conducted by this banana, is able to penetrate through some of these particles, or through some of this material like this one, which is less denser. Yeah, it can be able to penetrate through that material which is less denser there. But when we bring in more denser material, the voltage cannot be able to jump over it. So the monkey current that is crossing over this banana to the other banana is what determines the nature of this conductivity of this banana. Therefore, we can say that Banana themselves conduct electricity, but not necessarily by using the electrons or ions relationship. They are conducting the electricity because they have some kind of wavelength that we can easily see. And we can even change here and use the already one here so that the thing can be seen from both sides. I say for the bananas, there's no big change. In fact, when they become ripe, it's like when they increase in conductivity. So therefore, it will be the same. It will be the same using the same card. Can we use another card here, which is fresh card here? Separate the two bananas here, like that, and you shall still see that our LED lamp will indicate with even this new card there is conductivity of PD across the two bananas. Therefore, you can see I'm not lying that the banana itself is able to jump voltage across this card to the other side. Then when we remove this one, there is no conductivity. But when we bring them, then you can ask why there is no conductivity when you remove the card. It means that the air between the two bananas is a bad conductor of heat and electricity, as you know. Therefore, when I put this card here, what this card do, it eliminates the air there, therefore leaving room for the electromagnetic waves that are there to conduct electricity. Therefore, you can see it is purely being conducted by electromagnetic waves, and it is not being conducted by any relationship between ions or whichever you can say electrons. Therefore, short from what we have now been able to conduct today, it is easier for someone to say that the bananas or whichever fruit you eat, that they conduct electricity because of ionic relationship. We have used our own torch here to see that there was no spillage of any relationship. And then, even though it was there, then separating of the card itself, make sure that there is no spillage that can pass through the card. And you continue seeing that there was conductivity of voltage. So therefore, for today, that is the short lesson that we are going to learn here from Alien Lab. And it is very much important to see that from our Alien Lab today, we have learned that bananas or even the gophers are more good conductors of electricity than you know. Now you can also know that, thus indicate that in the future you can be able to make a conductor that are neither metallic nor ionic. It means that you can use metal, you can use conductors, or we can be able to make conductors from that relationship that are neither ionic nor metallic. Therefore, that short lesson from our K500 lamp and from our Alien Lab involving our K500 lamp and several multimeter is our first lesson and of a series of episodes that we are going to produce so that we can boost knowledge of electricity upon or people studying electricity in fruits and in plants. From our Alien Lab here in 2015, we say that for all the sponsorship that we have had from Spetnas, Sobasket Cleaner, and all the others, then we can say that in future we are going to produce more of these episodes, and as we see, there will be more and more interesting, and we can always, wherever you are in this world, whether in Canada, whether in Russia, whether in America, whether in Kenya or South Africa, you can comment on that experiment, and you can also conduct your own experiment and give us what is your view upon the experiment, because that experiment has been conducted over and over again. From the YURI James here from Alien Lab, I can say that until next time, thank you very much.